we shall have the 3 electrons. So this is 1, 2, and 3. So therefore the aluminium atom, in order to gain the stable electronic configuration, has to lose the 3 outermost electrons. Okay, so for us to form the aluminium ion, which is stable, with an electronic configuration of 2 to 8 and a charge of positive 3, which now will be, after losing the 3 electrons, we shall have still our nucleus at the center. The innermost electrons are not lost, so those ones remain 2. The 8 electrons were not lost as well, so those ones also remain. Okay, so these are 2, 4, 6, and 8. And therefore, this becomes the atomic structure now of that ion now, which is the aluminium ion. It has lost the 3 electrons, and that is why at the bottom here we can now say the aluminium ion loses the 3 electrons to form aluminium. The aluminium atom loses the 3 electrons to form the aluminium ion. So just illustrating here, the aluminium atom minus the 3 electrons, the E here denotes electrons. So after losing the 3 electrons, we form the aluminium ion with a charge of positive 3. Or simply you can say the aluminium giving us this aluminium plus the 3 electrons, meaning the 3 electrons were lost. Okay. So that's how we form the aluminium ion, and that is how simple. Now based on that, let's look at, suppose it is formation of sodium ion. The sodium atom with 11 electrons and electronic configuration of 2 to 8 to 1. So it has 1 electron more than the stable configuration of a noble gas. Remember noble gas, okay, most of the noble gases have 8 outermost electrons, or they have only 1 energy level with 2 electrons. Okay, so therefore the sodium wants to be stable like a noble gas, but it has to lose this 1 electron here. So during the reaction, the sodium loses the 1 electron in the outermost energy level or electron shell to become stable and form the sodium ion with therefore a configuration of 2. The sodium atom, which is again unstable, remember the sodium atom has atomic number 11, so its electronic configuration will be 2 to 8 to 1. So it has to lose this 1 electron here. And again in the atom, the number of protons is equal to the number of electrons, so therefore the charge is 0. Okay, so in our center here of the atom, we have the nucleus still. So the innermost energy level has got 2 electrons, those ones are never lost. The next one has got 8, which are also not lost. Okay, so we shall have the 8 as it is in there. Then in the last energy level, okay, it has 1 electron which must be lost for us to form the ion. So it has that 1 electron. So the sodium ion, which is stable, which in others now will have a configuration of 2 to 8, okay, and a charge of positive 1. Why positive 1? It's because we said the number of protons in an atom is equal to the number of electrons. However, as atoms form cations, as they lose electrons, the number of protons becomes more than the number of electrons, and therefore as we lose electrons, every time we lose 1 electron, the atom will be gaining a charge of positive 1s. In other words, the number of protons will be 1 electron more, and that is how the charge is gained. So when the sodium atom loses 1 electron, the remaining ion will have a charge of positive 1. So what is going to be our configuration? 2 to 8, and therefore our structure still will have a nucleus. The nucleus is not lost. The inner one will still have our 2 electrons originally here, so we shall have them here. Then the next second energy level will have the 8, which were not lost as well. So the 8 will remain. So we shall have the 2 there, the 2 there, the 2 there, and the 2 here, making the 8 electrons. And therefore this is now the structure of the sodium ion. Therefore, in order to continue illustrating, we can therefore say the sodium atom loses the 1 electron to form the sodium ion. Or we can say sodium minus 1 electron, giving us sodium positive. so a positive 1, or sodium giving us sodium and a sodium electron. So why are we putting the electron this side? Because we are implying it was lost. Therefore, that is how simple ions are formed. Okay. Then Roman 3. Suppose we say, let's look at formation of a lithium ion. Lithium atom has 3 electrons. If we go back to our electronic configuration, what will it be? 2 to 1. So again, it wants to be stable. It wants to have only 1 energy level with 2 electrons. It wants to resemble helium, which is a noble gas. So therefore, it has 1 electron more than the stable configuration of a noble gas of 2. Therefore, during the reaction, the lithium loses the 1 electron in the outermost energy level, okay, to become stable and form a lithium ion with the electronic configuration of only 2. Okay, again, if we are to illustrate, we have the lithium atom, which is unstable, electronic configuration of 2 to 1, the lithium ion, which is also stable now, electronic configuration of 2. So what happens? The atom has a charge of 0. It hasn't yet lost electron. So if we are to illustrate, we have our nucleus there, 1 energy level with 2 electrons. Then the second energy level with 1 electron. So it has to lose this 1 electron here, giving us now this stable configuration with a charge